Welcome, I'm Laurence Kornfield with the Department of Building Inspection, and we are here doing our Building San Francisco tour. Today we're going to have a very interesting tour of elevators in San Francisco. We've all gotten into an elevator, the doors have closed, and it's carried us to our destination. Have you ever wondered how elevators work? We'll explore the past, the present, and the future of elevator technology. As we ride on an ancient 1900s era elevator, we check out a unique outside elevator using current technology, and we learn about the latest destination elevator technology all here in San Francisco. We'll also visit elevator machine rooms where all the behind-the-scenes gear that controls these incredible machines is getting a dramatic update from 70s analog to the latest digital controls. We are very fortunate today to have an expert with us, George Van Clan, who's going to walk us around elevators in San Francisco. And George, can you tell us a little bit about the history of elevators in San Francisco?
Sure. The history of elevator technology really evolved very much with the growth of the city. So the first elevators installed in San Francisco around the 1860s for moving materials. In the 1870s, specifically at the Sheraton Palace, the first passenger elevator was installed. And that allowed building heights to go up to about 7 floors. And starting in the 1880s, 1890s, the first electric elevators were installed here in San Francisco, and that allowed for buildings to go even higher, up to 10 floors or even more than 10 floors. And those were the first elevators that really became representative of what we consider modern elevators today.
So the height of buildings is related to development of elevators then?
Oh, absolutely, yeah. I think the two key technologies for the emergence of what we consider the modern city are steel and elevators. Both of these technologies encouraged architects to design taller buildings. Engineering and material science provided a higher quality of steel to build with, and having passenger elevators meant that it was not necessary anymore to climb up a long flight of stairs to get to the top of the building. In fact, the elevator made the upper floors of the building a lot more attractive than they were before.
And here we are at the historic St. Francis Hotel, which is actually a representation of the evolution of elevators in many ways in San Francisco. Can you tell us a little bit about San Francisco history here at the St. Francis?
Sure. The St. Francis really demonstrates well the evolution of elevator technology. The hotel was originally constructed in 1904 and then substantially damaged during the 1906 earthquake, then rebuilt in 1907, 1908 time period, and extended again in 1913. And then a new tower was added in 1972. So there's all sorts of elevator technology that you can see at the St. Francis that very much represents the building history of San Francisco.
And I understand there's a really old elevator still operating here.
That's right, the Borgia elevator that was installed as part of the 1913 expansion, and we can go look at that.
Well, let's go take a look. So here we are in the spectacular St. Francis lobby. Isn't this wonderful?
Yeah, this really is beautiful.
Marble, Corinthian columns. And here's the clock. When people say, meet me at the clock at the St. Francis, this is it. Gorgeous thing. Lovely. Let's look at that elevator.
Okay, let's do it. So here we are in the Borgia elevator that was originally installed in 1913 as part of the expansion of the hotel in 1913. And this elevator is original. This is the way the elevator was originally installed about 100 years ago. This is a DC rheostatic elevator. It has a manual car switch, just like elevators did back in that period, and it runs on DC power. So this is from a time before elevators actually ran on AC power. This is running on the old DC.
When did they switch from DC to AC?
Well, the city started to switch around the country in the 1920s. So this elevator predates that by about 10 years. And as you can also see, the doors are also manual. So this elevator predates the use of automatic doors on elevators. There's a manual car gate and a manual sliding hoistway door.
Can we take a ride?
Absolutely. Okay, going down.
How many trips do you think this elevator makes in its lifetime? Millions?
Yeah, this has probably had certainly hundreds of thousands.
It's very smooth.
It really does run quite smoothly. Very nice.
There we go. Takes some serious operation. There we go. The Borgia Room, huh?
Yeah, this is really beautiful.
This is served by that old elevator we were just in.
That's right, yeah, and built at the same time, also built in 1913.
What a gorgeous room. I think we should have a party here, George.
I think that's a great idea.
Let's get up and look at the machine room for that old elevator.
Okay, let's go.
And here we are in the machine room for the Borgia elevator with all this wonderful old sort of early industrial era equipment.
That's right.
Cast iron. Tell us what we got here, George.
Well, this is really the beginning of a modern elevator. So this is what we would describe as a overhead traction geared elevator. And that type of elevator still exists, and even though this was made in 1913, elevators like this have continued to be manufactured up until the present day.
So overhead means these cables attached to the top of the car?
Correct, exactly right.
Hoist the car and drop it down?
Yes.
Okay.
Our hoist machine is located overhead, over the cab. And this is a traction machine, so it's an evolution beyond the winding drum elevator. This is the drive sheave. This is the gearbox of the hoist machine, and this is original from 1913. It's a heavy-duty design that we really don't see anymore today. This is what's called a tandem gearbox, and that's probably part of the reason why this elevator's already lasted close to 100 years. And this is the brake for the hoist machine.
And we have the original controller here.
That's right.
Fortunately, the power's turned off. There's like no room in here, and it's all hot and everything moving. It must be quite exciting.
Part of the reason for that is that this room was built in 1913, but the National Elevator Code actually wasn't introduced until 1921.
So George, tell us about this antique controller we're looking at here. How does this operate? And what makes it different from a modern controller?
Well, this is a DC rheostatic controller because this elevator is actually running on the original DC power. And really very simple in operation, does not include a lot of the features we would normally have in an elevator today, automatic door operation, automatic dispatching, push button operation. None of those features are present in this controller, but this is the original controller from 1913. So Laurence, here's the controller, and on this side of the controller we have all the relays that actually control the elevator. The safety circuit, the position, speed, and the control of the power to the motor.
And here is a really interesting piece of historic machinery. George, tell us about this.
Well, this is one of the main safety devices of the elevator system, and in fact this device still exists today even on modern elevators. This is an Overspeed Governor that detects if the elevator is going into a unsafe overspeed condition. This rope here is attached to the car itself, and if the car overspeeds, then as the sheave is turning, these fly balls would come out, and the governor jaws would grab onto the governor rope, which would pull the brake or the safeties on the elevator to cause it to stop.
And if you have problems with any of this elevator equipment, I see it says right here, we call Garfield 7171 for service. This looks like the original service details here.
That's right, operator standing by.
Right, operators are standing by. So from here we're going to go look at those wonderful elevators that go up the outside of the high-rise building that everybody wants to take a ride in.
Let's go do that.
Great, sure thing. Well, here we are in the most exciting elevator in the city of San Francisco. This is the outside elevator that goes up to the 32nd floor. And tell us a little bit about this elevator, George.
Well, so we're in one of the tower elevators now at the Westin St. Francis. These were originally installed in 1972, 1,000 foot a minute, outside observation elevators, so a great view of the city. And some of the most popular elevators in San Francisco, as you mentioned.
Yeah.
And these cars run a lot. They run about 2,000 starts per day, so about 700,000 starts per year for an elevator like this. So these are pretty hard-working elevators.
It must be hard to maintain these elevators. They're sitting outside and they have, mechanical devices in the rain and
That's
fog.
Right. Yeah, this is much more difficult to maintain. Normal elevator installation is all sealed from the elements, but in this case it's all exposed to the outside, so there are major issues here with weatherproofing and sealing the equipment from the elements.
And the controls and the motors are all up here on the top floor.
That's right, and very similar to the Borgia elevator that we looked at. This is sort of an evolution of that technology. This is an overhead traction machine, yet again, with a big gearless machine up in the roof.
And I saw a crowd of people downstairs waiting to take the ride on the elevator to get this fabulous view. That is a terrific view, isn't it?
Yeah, that's great, yeah.
So can you tell us a little about the history of the modern elevator?
Sure. Well, what we consider the modern elevator is the elevator with a safety device that was developed by Elijah Graves Otis in New York in 1853 in response to a freight elevator accident in New York City. And up until that time, elevators were actually quite common in buildings, but typically used just for handling freight. Elijah Otis then successfully demonstrated the safety device that he developed at the New York Exposition in the Crystal Palace. And Otis went up in the elevator and he cut the hoist ropes with an axe and he didn't fall. And that really impressed everybody in the audience, and his famous quote from that event is, "All safe, gentlemen, all safe." Then a few years later, in 1857, the Otis Brothers Company actually installed their first passenger elevator in the E.V. Hallwood building on Broadway in New York. And actually, Laurence, believe it or not, many of those first elevators were actually started and stopped by a hand rope.
So George, what drove those old elevators? What was their motive power?
Primarily steam. In some cases, they might have been manually operated or even horse-powered.
And then changed to electric?
Changed to electric, yeah. Electric motors started to come about for elevators in about the 1880s. And that was around the time when elevators stopped being just for material handling and started to be used more frequently for passengers. So in 1878, Werner von Siemens demonstrated the first electric elevator at a trade exhibition in Mannheim, Germany. Now, the other thing that allowed architects to design taller buildings, of course, was the advent of a higher quality steel manufacturing. And in 1903, the first production model gearless traction elevators were introduced, and that really allowed for even taller buildings. And that was really when things took off.
And that mostly happened in New York City and around there, is that right?
Yeah, Lower Manhattan was really the first place where that really took off, then Chicago. But also we had buildings here like the Palace Hotel that got their first passenger elevator in 1875. And you know, those early passenger elevators always had an attendant who would take the passenger floor requests and then operate the controls inside the car. I think the big change was the emergence of electric elevators. Starting around 1880, the electric elevator allowed for buildings and elevator travel to get much higher. And that's the technology we basically have today. So we evolved from steam and hydraulic elevators to electric elevators that aren't actually that much different than what we're going to go see right now on the top of the tower. This is the machine room for the tower at the St. Francis. A total of 8 elevators up here, 5 passenger cars and 3 service cars. This was all built in 1972, and the equipment that you see that's painted green, the hoist machine, the selector, the controllers, that's all the original equipment from 1972, and we are just now in the middle of modernizing all this equipment.
Now, why would you modernize? Doesn't it work fine?
Well, you know, the equipment does work fine, but this is an older technology. It's all analog, very maintenance intensive, and there's a lot of things now that can be done better with digital controls. Let me introduce the foreman to you. This is Vince Marino with Otis, who can do a better job explaining some of the project details. This is Laurence Kornfield.
Oh, hi Laurence, how are you? Hi George.
So Vince, what's happening here? What are you doing?
Here we're doing a major modernization. So what we're doing is we're tearing out the old positioning system, we're tearing out the old relay logic controls, and we're getting rid of all the generator control. And we're going over to solid state.
This is a selector, right?
This is a selector. This tells us the position of the elevator. This is not a standard selector because it does not have a tape that runs it. This is actually, because these are outside elevators, this is very unique to San Francisco. There's not another one like it in San Francisco.
And this one is going away with this upgrade, is that
All
right?
this goes away. At the end of the project, we won't have any of these in here. And there's 5 in here now. We've already retrofitted 3 of the elevators with the service elevators here, so now we're doing the outside cars.
So Vince, this is what is replacing all of that?
This is actually replacing most of the components, the generator control system and the controller. This is now a processor drive system. We've got down to probably 15 to 20 relays as opposed to 100 relays on there, which is a lot less maintenance, a lot less draw. It's a finished unit. We've got to tidy up some wiring and put the covers on it. And this thing's been running for about 6 months now, but we've got 8 cars in here to finish, so we still have a little bit of things to change and to do.
Great job. We've looked at elevators past and present. Now let's look at elevators future. We're here at 1 Front Street to look at some of the most exciting innovations in elevator technology. These are destination-based elevators which address security, sustainability, disabled access. George, tell us a little about destination elevators.
Sure, thanks, Laurence. This is the technology of the future. Probably the biggest single advance in elevators of the last 50 years. And San Francisco has probably embraced this technology more than any other city in the country. Big advantage with destination elevators is that passengers get to their floors sooner, and there's a lot more opportunity for customization of features for individual service. So for issues like security or accessibility, this is really a big advance over conventional elevators.
Let's take a look.
Okay.
So George, I understand that these are rehabilitations, upgrades of the existing elevators, is that right?
That's correct. Yeah, these are the original elevators from 1980.
And the same motors, same cabs, just new control systems.
That's right. All the controls, all the wiring, that's all been changed, but the physical mechanism is actually the same.
Mm-hmm. And these are sustainable, they have sustainable features, they use less energy. How much less do they use? Do you have any idea?
Well, on a project like this, with all the different things that we did, Laurence, the energy savings is about 50% from where we started to where we are today. So that's actually a pretty significant improvement for such a major building system.
So tell us a little bit about the system and how it works.
Okay. Well, this is a hall keypad. So this replaces the conventional up and down hall buttons. And the most important thing to understand about destination elevators is that the system asks where you're going before you get into the elevator. So imagine you were going to the airport. You wouldn't just hop on the first airplane that was departing. You would wait until you got the airplane that was going to the city where you wanted to go to. So the same thing here. And all we do here, instead of pushing an up button, we just put in the floor that we're going to. So in this case, we follow the instructions, and we're going to the 9th floor, so we push 9. And this building has security, so I also have an access card, and that will give us permission to go to the 9th floor. And then we just go to the assigned elevator, which happens to be elevator A. So why don't we head up?
And this is only stopping at floors 4 and 9. I don't see any push buttons in here at all, except maybe hold the door open a little bit and an alarm.
Well, that's right. We just have the standard buttons that are required by code and for safety, but there's no need to have buttons in the car anymore.
And there's on each floor, there's a place to enter your destination.
That's right. Just like we saw at the ground floor, there's keypads in the lobby.
And it doesn't make a whole lot of stops. It just goes to your floor and it sorts everybody out, so it doesn't have to make multiple.
Exactly right. The system efficiency in terms of traffic handling, because we don't have to make as many stops, is really a big improvement.
Going up.
We've invited Jesse Laurence from the Center for Independent Living to come and tell us how destination elevators interface with persons with disabilities.
When destination elevators first started appearing in San Francisco, they presented a number of challenges to individuals with disabilities. Essentially, what happened is elevator technology outpaced California Building Code. And California Building Code has a number of provisions that make traditional elevators usable by people with disabilities, but destination systems presented a lot of challenges, particularly when it comes to signage. If you can't see, how do you know to get from this keypad to your appropriate car?
So we had this terrific program where we developed an administrative bulletin with your help and the elevator companies, lots of involvement from the public. And you can tell us a little bit about the outcome of that bulletin.
Well, what's amazing about the process is we had both government and private industry, as well as people with disabilities, at the table for almost 3 years creating these accessibility standards. And what we've created here in San Francisco is being looked at by the Department of State Architect's Office and the Department of Justice's Access Board. That's how good our standards are here in San Francisco. Do you want to see?
Please.
Okay, so I'm going to push the access key, which is going to activate the voice.
Please enter destination floor.
I'm going to go to floor 24.
Floor 24. Proceed to car J.
To the left. Let's go.
Elevator J, as in Juliet, has arrived.
That was a smooth, fast ride.
Oh, isn't that
It's
nice?
Great.
Oh, I'm getting a text message here. Oh, you know, Laurence, it's really amazing, these destination systems. Pretty soon, the signal that controls the destination-oriented system is going to be able to be routed through Bluetooth into the cell phone, which is amazing. My iPhone talks. All of the functions on the iPhone I'm able to access using my ears instead of my eyes. What's interesting is in Paris already they're routing the accessible pedestrian signal through Bluetooth into people's cell phones. So the future is really exciting, and I think technology is going to make it quite the journey for everybody.
Very neat. Well, thank you for joining us, Jesse.
Oh,
Appreciate
thank
it.
you for having me.
Going up.
Well, so now I'd like to introduce the chief engineer of 1 Front Street, Brent Martin. Hey, Brent.
Hi, George.
And you know what? Can you tell us a little bit about your experience with the modernized elevators?
Well, there were a lot of anticipation as to what people would do and how they would respond. And at first, we had to really get in front of people to direct them from their habits, because early morning, they'd be more into carrying their coffee and donuts and going inside of the elevator and then spilling their coffee to hit the keys. And so we've got right in front of them, stopped them, and pointed exactly what they would have to do. And that helped out a lot. Mm-hmm. The other thing that helped out was the lights in the lobby would tell them where the elevator was. A lot of these systems have not done that. We were the first building to do that, to light up the hall call lanterns. The nice thing is we got less spills in the lobby too, because you know how you get in the elevator in the morning, you've got a lot of stuff, your briefcase, coffee, and then somebody's standing in front of the buttons and you can't even, you can't get to it. So people are fighting each other, spilling coffee and stuff. And so this worked out real well, because once you get inside the car, you're going to the floor you've decided on the outside. And so that helped a lot. It really improved traffic flow and security as well.
And so would you say your experience has been a good one?
Excellent, very positive.
Oh, great. Well, let's go for a tour of the machine room.
Great. Here we have the network control, and this handles all the elevators in this one group, which is the midrise group. There's 2 of them. In case one fails, there's a backup, so there's automatically redundancy. And each one of these Ethernet cables connects to all the devices and communicates with the main global server at the security console. The previous equipment was a relay control, and it was analog logic. This has many advantages in that it can be custom programmed and it can automatically readjust to changes. And it can do a multitude of things, like the lights that lit up in the lobby and blinked. Those were all programmed through this type of equipment. Before, this whole room was filled with giant relay panels that click, 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 and had relays. And in order to know where the elevator was on the floor, they had this big switch that would rotate around and had to tell the elevator where it was located. We can level these cars within 1 millimeter. And it used to vary depending upon the temperature, by up to ½ an inch. And that was a tripping hazard. Now you walk out in the elevator and it's a smooth transition. It's very important for the disabled as well. Over here is the controller. And what this does is it provides information to the elevator where to go. It receives commands from within the elevator and from the destination dispatch central up on the floor here. It gives directions on braking, and elevators are entirely electrically braked, so they have to be precisely slowed down to level exactly at the floor. And it's very, very precise. It coordinates with the VFD to supply power to the elevator motor, which is right here. These is the original DC drive. DC drive was in place since the beginning of elevators. It was easier to control. Currently, new elevators are done differently. They're AC drives. But they're so expensive to replace and such a waste of materials, and they work very well. We made it more efficient by providing a new electrical system to drive it. The Quattro drive, which is controlled by the same transistor that controls the Toyota Prius. And the advantage of that is when the elevator is going up empty, the counterweight actually pulls the elevator, and this generates electricity by braking. Same thing as in a Toyota Prius or another hybrid car. When you hit that brake, it's using electricity to brake the car through a motor. This does the same thing. Here inside we have the guts of the IGBT drive. This right here has precise generation of power, which is important for highly accurate level landing of the elevator. Also the acceleration, deceleration, which can add to instability of somebody disabled in a car, is reduced. This kind of gives you a summary of the power supply that we use in our destination dispatch system.
So we've taken a ride in an antique elevator.
So here we are in the Borgia elevator. This is the elevator that we mentioned outside that was built in 1913.
Industrial era equipment.
That's right.
We've checked out current elevator technology.
These were originally installed in 1972. 1,000 foot a minute outside observation elevators.
This is not a standard selector because it does not have a tape that runs it.
We've seen the future of elevator technology.
And all we do here, instead of pushing an up button, we just put in the floor that we're going to.
So I'm going to push the access key, which is going to activate the voice.
Please enter destination floor.
This right here has precise generation of power, which is important for highly accurate level landing of the elevator.
And what happens next, none of us know, but it's going to be exciting. Thank you, George, for showing us this really interesting technology.
Thank you, Laurence. It's been my pleasure.
It's terrific, and we look forward to having you join us for the next Building San Francisco.